Hello everyone. Uh, I'm Karthik Mahadevan, and let's continue this course on revision or a review of high school mathematics so that we can go ahead and learn college mathematics. And the topic that we're going to cover now is quadratic equations. We have already covered linear equations in, I guess, sufficient detail so far. Those who already know linear equations, what is a variable, what is a solution to an equation, you could directly watch this video. Otherwise, I would suggest that you check out the two videos on linear equations. So now that I have described what I had already described what an equation is, I had described what a solution to a linear equation is. The same remains true for a case of a quadratic equation. But let me first explain what is a quadratic equation. Uh, As in my linear equations video, I have explained that equations can contain n number of variables. Alright. Currently, we are only going to discuss equations containing one variable. In this particular course about quadratic equations, we are only going to discuss equations in one variable. But equations that look something like this: x squared plus 5x plus 3 is 0. Say an equation something looking like this. I'm sure you must have covered this in high school. This is what we call as a quadratic equation. Basically, any equation that looks like this: some number a times x square plus some number b times x plus some number c equals 0. So any equation that looks of this kind, that has this form, is a quadratic equation in the variable x. All right. Note that here a has to be a non-zero number, because if a is 0, essentially it just becomes bx plus c equals 0, which is a linear equation. Note that in a linear equation, the power of x, all x, the power of x was 1. Here the maximum power of x is 2 in a quadratic equation. We will only discuss quadratic equations in one variable, so we will only discuss about equations of the form ax squared plus bx plus c equals 0. Suppose I have an equation x squared minus 1 equals 0. Does this qualify as a quadratic equation? Think about it. The answer is yes, because if you compare, it is of this form where a is 1, b is 0, and c is just minus 1. So it does comply with this form, and a is non-zero. So again, just like we discussed in linear equations, a solution is something, the value of variable that satisfies the condition or satisfies this equation. So what is the value of x? In principle, as I said, x is a variable, so it can be anything. It can be 1, it can be 2, it can be 1.5, x can be pi, etc. etc. It's a variable, its value can vary. But there will be only few values of x that actually satisfy an equation. In this case, there is only one value of x, that is x equal to 1 is the only value of x that actually satisfies this equation. Okay, so x equal to 1 is the solution of this quadratic equation. Suppose we have x square minus 2x plus 1 equals 0. Okay, this is a quadratic equation. I would like to find out what is the value of x such that this equation holds true. Now, before we, just like in linear equations, we talked about how to solve linear equations. Here we would talk about how to find the value of x such that ax squared plus bx plus c is 0. So we'll cater to the problem how to find the solution of a quadratic equation. I'm sure most of you must have covered this in high school, but we'll still quickly talk about all of this so that we are ready to deal with college level mathematics. So before we talk about solving quadratic equations, we need to understand a very important thing. And that very important thing is we need to quickly revise three formulae that you might have learned in high school. The first one being a plus b the whole square, and that is just a squared plus 2ab plus b squared. How do we get this? You just take a plus b, a plus b. There's no need to memorize this. This gets multiplied with this, so that a into a is a square. This will get multiplied with this, so that will be ab. This will get multiplied with this, so that is ba, and this will get multiplied with this, that is b square. Note that 2 into 3 is 6, 3 into 2 is also 6, so a into b and b into a are the same thing, so you can write it as a square plus 2ab plus b square. This is one formula that you must remember, and I'm sure that if you have completed high school mathematics, you would recognize this very easily. Similarly, a minus b the whole square is a square minus 2ab plus b square. Right, this is another formula, and you can easily derive this formula as well. The third one being that a square, a minus b into a plus b is just a square minus b square, or a square minus b square is a minus b into a plus b. So these are three important formulae or expressions that you should remember so that we can easily solve quadratic equations. If you think about it, the equation that we first discussed, x square minus 1 equal to 0, it is of the form x square minus 1 square is 0, isn't it? 1 square is 1, right? You can rewrite it in this form. This just looks like a square minus b square, alright? Sorry about that, I made a mistake over here. Let me correct that. I said that there is only one value of x, that is x equal to 1, that is a solution to this equation. I'm really sorry about that. Even x equal to minus 1 satisfies this equation, because even minus 1 square will be 1 and 1 minus 1 will be 0. So yeah, for this particular quadratic equation, x square minus 1 equal to 0, there are two solutions. Okay, so if I rewrite it in this form, x square minus 1 square equals 0, this is like a square, this is like b square, right? So a square minus b square can be written as a minus b, a plus b, 0. So I can write it like this. Okay, if I can write it like this, then if you think about it, it is like saying the number x minus 1 into the number x plus 1 is 0. Note that the product of two numbers can only be 0 when the number itself is 0. So either, so like 2 into 2 cannot be 0, 2 into 0 is 0, or 0 into 3 is 0. So for this to happen, either x minus 1 must be 0 or x plus 1 must be 0, which means x can either be minus 1 or x can either be plus 1 for x square minus 1 to be 0. So we have solved the quadratic equation. If a quadratic equation is in this form, it's really easy to solve. Now, if you think about it, if I have the equation ax squared plus bx plus c equals 0, now it might seem that I'm going to jump the gun a little bit, but pay attention. If somehow, somehow, if somehow I was able to rewrite this expression as x minus a into x minus some value capital B is 0. Now note that this capital, it's not small a, this is capital B, this is not small b. Somehow by magic, if I was able to write x minus this equation in this form, then by the same argument, I can say that for this to happen, x minus capital A must be 0 or x minus capital B must be 0, which would imply that x equal to A or x must be equal to B, which means x equal to A is the solution to the quadratic equation and x equal to B is a solution to this quadratic equation. So if ax squared plus bx plus c equal to 0 can be rewritten as x minus some value a multiplied by x minus some value b equals 0, then we can directly say that x equal to a is the solution of a quadratic equation and x equal to b is also the solution of the quadratic equation. All right. So we can say x equal to a is the solution of this quadratic equation and x equal to b is the solution of this quadratic equation, provided we can write it in this form. So either you can try to factorize this and try to write in this form, and that won't be possible in all cases. So we will see how this can be rewritten in this form. Essentially, if you can write this in this form, it's done. You have the solution, right? If you can write this in this form, you know the solution. This is one method of solving quadratic equation. That is, you try to manipulate it somehow so that you can rewrite this as in this form and then you can get the solution. A quadratic equation can have a maximum of two solutions. Okay, so if we take a linear equation, a single linear equation in one variable, x minus 5 equals 0, this has only one solution, x equals 5. But as we have seen, x square minus 1 equal to 0 has two solutions, x equal to 1 and x equal to minus 1. So a quadratic equation can have a maximum of two solutions. If we take the equation x square plus 2x plus 1 equal to 0, this, if you recall, this is just a square plus 2ab plus b square, where a is x and b is 1. So this is just x plus 1 the whole square equals 0, which is just x plus 1 into x plus 1 being 0. So if only if x is minus 1 does the equation become 0. Otherwise, the equation does not become 0. Okay, so this equation has only one solution. So a quadratic equation at max can have two solutions. It can have one solution. We'll go ahead and further in this lecture, or maybe this will be a two-part lecture. So in the next lecture, we'll look at quadratic equations that have no solutions. Okay. Now, what we have seen is that if I'm able to write any equation of this form in this form, I know what the solutions are. By the way, this is what people will call as roots of the quadratic equation. It is just another name for solution. So if somebody says x equal to a and x equal to b are the roots of the quadratic equation, they just they are just trying to say that x equal to a and x equal to b are both solutions to the quadratic equation. So one way is you rewrite this in this form so that you get a solution. Or as seen here, if I have, if I can write this as a square plus 2ab plus b square, that can be just rewritten as a plus b the whole square. So if I have something like this, I can just get something like this and I have a solution. Okay. So now we are going to develop a general method to solve any quadratic equation. Okay. Either you can try to factorize this ax square plus bx plus c and rewrite it in this form so that you can solve the quadratic equation, or you can use the general method which I'm going to discuss now to solve the quadratic equation. Let's take, we have a general equation ax square plus bx plus c is 0. Okay, let me divide this equation throughout by a. I can do that, right? If 2 times 2 is 4, I can say that 2 times 2 times 2 is 8. I can multiply equations by number, I can divide equations by number. Let me divide this entire equations by a, and a is non-zero, that's my condition. So I'm not dividing by 0. So I will get x square plus b by ax plus c by a is 0. This is what I get. Now, suppose I'm um, using a word, suppose this could have been written as, suppose this could be somehow miraculously written as sum 2ab, and if this could have been written as sum b square, then this could be rewritten as, sorry, if this could be written in this form, forgive me, if this could be magically written in the form a square plus 2ab plus b square, I can just simplify this as a plus b the whole square. Essentially, I could have just written it as x plus some number n the whole square equal to 0, and I get the solution. So here's the question. I have the now my equation x square plus b by a x plus c by a is 0. If if I want this to be, so this is like my a square. This is a. So if I want this to be of the form 2 into a into b, that means my 2 times b must be b by a, which means my b should be nothing but 2b by 2a. If my b is b by 2a, that means this term is of the form 2a 2ab. All right. Now, if I had a b square term, then my job is over. If c by a was just b square, then my job is over. I can just write this as x plus some number n, and that some number n is going to be b by 2a. The whole square is 0. That means x plus b by, sorry about that, x plus b by 2a into x plus b by 2a is 0, which means x is just minus b by 2a. I get my answer, and it is just one solution in such a case. But there's no guarantee that uh, b by 2a, the whole square, right? That is my b square, b by 2a the whole square, which is b square by 4a square, that and c by a are the same thing. If those are the same thing, then I can directly write it in this way and I get a solution. It's not necessary that c by a should be equal to b square by 4a square. However, I've written this as a square plus b by a x. I've written this as 2 into a into b, where my b is now b by 2a. Now hold on, pay attention. This is one of the most important things in mathematics. If I had x squared, I already have a term of the form 2ab. If I had a b square term, sorry, a is just x in this case. If I had a b square term, I could have just written it as x plus b the whole square. But I instead have c by a over here. So you know what? I have the equation x square plus b by ax plus c by a is 0, and I've already said that this is of the form 2 into a into b, where a is just x and b is just b by 2a. Okay, suppose I had a b square term, I could write it as x plus b the whole square. So you know what, I will just multiply, sorry, I'll just add b square on both the sides. Can I do that? Yes, if x is 2, I can say x plus 1 must be 3, right? I can add a number on both sides. Let me add b square, but what is b square? B square is essentially just b by 2a the whole square, which is b square by 4a square, which this is just b by 2a the whole square. So this is now just x plus b the whole square, which is just x plus b by 2a the whole square. Do you agree with this? Pay real, pay careful attention. This is very important. So now my equation is of the form x plus b by 2a the whole square plus c by a is equal to b square, which is b square which is b by 2a the whole square, which is b square by 4a square. Which means I can rewrite this as x plus b by 2a the whole square equals b square by 4a square minus c by a. Can I not write it like this? Which means if I just multiply this and if I just multiply this by a and this by a, I can just write it as x plus b by 2a whole square is just equal to b square minus and I also need to multiply this by 4. I'm making the denominator common. So I will multiply this by 4a to get 4a square in the denominator. So I'll get b square minus 4ac by 4a square. I will get this. Suppose I have x plus 1 the whole square equals 1. That means if I take square root on both the sides, x plus 1 should be equal to 1. Note that x plus 1, if I take square root on both sides, some yeah, x plus 1 equal to 1, or a square root here. Suppose you have x plus 1 the whole square is 4. Okay, so you have x plus 1 the whole square is 4, but 4, note that 4 is minus 2 square, it is also 2 square. So yeah, if I have square root x plus 1 the whole square, if I have x plus 1 the whole square is 1, if I take square root on both sides, square root of 1 is just 1. Square root of x plus 1 the whole square can either be x plus 1 or it can be minus of x plus 1. Do you agree? Because 2 square is 4 and even minus 2 square is also 4. Sorry, minus 2 the whole square is also 4. So x plus 1 the whole square, if it is 1, it means that if I take square roots on both sides, x plus 1 has to be 1, or minus of x plus 1 could have also been 1. So now if you square both sides, square of this is x plus 1 the whole square, square of this is also x plus 1 the whole square. So here you get x equal to 0, or you get minus x is 2, so x is minus 2. So in both the cases, this equation is satisfied. So coming back to our main equation, we have this. If I take a square root on both sides, that means plus minus x plus b by 2a by the same logic. X plus 1 can be 1 or minus of x plus 1 can be 1. Plus minus x plus b by 2a can be the square root of b square minus 4ac by 4a square. Actually, even when you take this square root, or perhaps, okay, let's leave it in this way. Plus minus x plus, this is just a number whose square root has to be taken. Which means I can write plus minus x plus b by 2a equals square root b square minus 4ac. Note that the square root of 4a square is just 2a. You might say that even minus 2a square is 4a square. Yes, you are correct. And perhaps you could have written this as minus. But because this is plus minus anyways, uh, that is same as saying If this is minus on this side, then the equation becomes x plus b by 2a equals this. If it is plus on this side, then it becomes minus here. So there's no need to put signs on both sides of the equation. If plus minus something equals plus minus something, that just means plus minus something equals something. I hope you understand. Because if this is plus, it's plus on this side. It's plus on both sides. This is minus, this is plus. This is just like having minus on this side. If this is minus, this is also minus. It is like having plus on both sides. And if this is minus, this is, or if say this is plus, this is minus, I can shift this and write it as minus here and plus here. So there's no need to put signs on both sides of the equation. So essentially, you just get plus minus x plus b by 2a equals square root b square minus 4ac divided by 2a. You just get this. I can just put these signs here instead, which means x plus b by 2a can be plus or minus b square minus 4ac by 2a. Let me bring this on this side, which means x equals minus b by 2a plus or minus square root b square minus 4ac by 2a. Therefore, x is just minus b plus or minus b square minus 4ac divided by a. We have derived what is called as a quadratic formula. Okay. So this given any quadratic of the form ax square plus bx plus c equal to 0, no need to bring it in the form x minus a into x minus b equals 0. You can directly use this formula, directly use this formula, you can directly use this formula to get the roots, and there will be two roots. Okay, there will be two roots. There will be one root will be minus b plus square root b square minus 4ac by 2a. There could be a second root minus b minus square root b square minus 4ac divided by 2a. And there is also a possibility where x1 is x2, that is when we say we have a single root. Okay, note that this number could be negative. Suppose we have x square plus x plus 1 equal to 0. Here a is 1, b is 1, c is also 1. So b square minus 4ac is just 1 square, which is 1, minus 4 into a into c, 4 into 1 into 1, it's 4, it's minus 3. And now what is the square root of minus 3? You cannot imagine, right? Because, well, square root of, if you say square root of 4, well, 2 square is 4, which means the square root of 4 is 2. But even minus 2 square is 4. So square root of 4 can also be minus 2. But if you square a positive number, you always get a positive number. If you square a negative number, still you get a positive number. So there is no way that there exists a number on squaring, you will get a negative number. Essentially, when you say what is square root of 3, if some value say, sorry, let's not call it x, if say y is say square root of minus 3, what do you mean? You mean that y squared is minus 3, but there exists no number y in the world such that if you square y, you will get a negative number minus 3. Because if y is a positive number, y square will be a positive number. Even if y is a negative number, y square is a negative number. So, square root of a negative number doesn't exist, which means a solution, there exists no real number x such that it satisfies the quadratic equation ax squared plus bx plus c equals 0. So in this case, there exists no real number x in the world that is a solution to this equation. So if square root b square minus, or just the term b square minus 4ac, if this is negative, then you will have no solution. Okay, so we call this as the discriminant delta, b square minus 4ac. If this is negative, less than 0, then there is no solution. Note that if delta is 0, which means b square minus 4ac is 0, so x1 will just become minus b by 2, and x2 will also become minus b by 2a, which means x1 is equal to x2, which means there is actually only one solution, that is x1. So if delta equal to 0, there is one solution, and if delta is greater than 0, only then you will have two solutions. So the entire quadratic equation problem can be summarized in this way. Okay, if you have an equation of the form ax squared plus bx plus c equals 0, that means the solution x is minus b plus or minus square root b square minus 4ac divided by 2a, and this quantity delta is b square minus 4ac. So you can directly calculate delta first. If delta is less than 0, it has no solution. The quadratic equation has no solution. There is no value of x that can satisfy this equation. If the value of delta is 0, there is only one solution. And if the value of delta is greater than 0, then there are two solutions. There are two values of x that satisfy the quadratic equation. Okay, so we have covered this part. I think I went a bit fast, but you can watch this again and again to understand. So many people try to mug up this formula, but I have systematically derived this formula. It's very logical. If we go back, the entire idea was to make a perfect square. So was to use the formula a plus b the whole square. And the entire idea was to bring this of the form x plus something the whole square. And that's what we did here. Okay. One last part. If I told that this can have two solutions. So let's say, and I also told that solutions of a quadratic equation are known as roots. Let's say somebody says alpha and beta are the roots of the quadratic equation. But as we have seen, if this can be written in the form x minus some value a into x minus some value b is 0, a and b are the roots. So if alpha and beta are the roots of the quadratic equation, if alpha and beta are the roots of the quadratic equation, which means x minus alpha into x minus beta must be 0. So which means the quadratic equation can actually be written in this form as well. Okay, it can be written in this form as well, which means x squared minus alpha x squared minus alpha x minus beta x plus alpha beta is 0, which implies x square, you can take minus common, alpha plus beta times x plus alpha beta is 0. So if alpha and beta are the roots of the quadratic, if you know the roots of the quadratic equation, so if somebody tells you that x equal to 1 and x equal to 2 are the roots of the quadratic equation, so this is alpha, this is beta, you can actually find out what the original quadratic equation is. So your original quadratic equation will be x square minus alpha plus beta, it's 3x plus alpha into beta. This is the quadratic equation. So given the roots of a quadratic equation, you can tell what is the original quadratic equation whose solutions are these. Okay, but we have also told that any quadratic equation can be written in the form ax squared plus bx plus c equals 0. So if I divide this by a, I can say x squared plus b by ax plus c by a is 0. But if alpha and beta are the roots of my quadratic equation, if alpha and beta are the solution to my quadratic equation, by comparison, can I not say that minus of alpha plus beta should be b by a, which means alpha plus beta is minus b by a, and by comparison alpha into beta should be c by a. So even though you need to actually solve the quadratic equation this way to get the roots, you can say that the sum of roots of a quadratic equation is minus b by a, and the product of the roots of a quadratic equation is c by a. And actually, if you just see, x is minus b plus minus square root b square minus 4ac divided by 2a, which means I can say alpha, one of the roots, is just minus b plus square root b square minus 4ac by 2a. Beta, the other root, is just minus b minus square root b square minus 4ac by 2a. If you add these two, alpha plus beta, this term is plus, this is minus, it will get cancelled. Effectively, you will get minus b by 2a minus b by 2a, which is just minus b by a, which is the same as what I have obtained here. And if I multiply alpha into beta, if I multiply alpha into beta, this is like some value, say a, this is like some value b. All right, so this, sorry, this is like some value a plus b. This is like some value a minus b. So it's just a square minus b square, which is b minus b by 2a, the whole square, minus this thing, square root b square minus 4ac by 2a, the whole square, which means I'll just get b square, and here I will get minus of b square minus 4ac divided by 4a square, which is just b square gets cancelled. I'll just get 4ac by 4a square. 4 can be cancelled out. This is just c by a. And that's exactly what we got here. So to summarize this entire lecture, quadratic equation is anything of the form ax squared plus bx plus c equal to 0, where a is not equal to 0. If you can write this of the form x minus some value a into x minus some value b equals 0, or x minus alpha into x minus some value beta is 0, then x equal to alpha and x equal to beta are the solution to this quadratic equation, and these are known as the roots of the quadratic equation. A quadratic equation can have at max two roots, it can have one solution or one root, and it can also have no solution. The solution to a quadratic equation of this form is x equals minus b plus or minus b square minus 4ac by 2a, where this value b square minus 4ac we can call as delta, which is the discriminant. It's discriminant because it discriminates between the different types of roots. Okay, so if delta is less than 0, then we have no solution. If delta is 0, we have one solution, and if delta is greater than 0, we have two solutions. And finally, uh, if a quadratic equation ax squared plus bx plus c equals 0 is present, the sum of the roots alpha plus beta is just minus b by a, and the product of the roots alpha into beta is just c by a. So with this, I have concluded uh, the theory of quadratic equations. So yeah,